Hey guys, welcome back to my channel University Physics. So we are solving quantum physics by H.C. Verma. We have completed chapter 1. So let's move to chapter 2 and question number 1. So in question number 1, it is said that there is a polarizer whose transmission axis is parallel to the y-axis. Here you can see, and a beam of light which is moving along z direction, and its amplitude it's vibrating along the x-axis and y-axis. So basically this E1 corresponds to x-axis and this E2 corresponds to y-axis. So we have to calculate that uh, probability. We have to find the probability that a given photon will be transmitted through the polarizer. So this is y-axis, and the axis of transmission, the transmission axis of the polarizer, is also kept along the y-axis. So the electric field is given as E is given as magnitude E naught times 5 E1 cap plus 12 E2 cap. So E1 corresponds to x-axis and E2 corresponds to y-axis, and this is same as transmission axis of polarizer. So any vibration parallel to the axis of the polarizer will transmit through the polarizer, and perpendicular, that is x, any electric field which is vibrating along the x direction and the y direction, or x direction or z direction, will not transmit through the polarizer. So let us just change the notation. We can let's denote E as ket psi. This is not equal, we are just denoting it, writing in terms of the basis states that we use in quantum mechanics. Dirac notation we are using basically, and direction E1 cap, let's say it ket phi 1, and direction E2, let's call it ket phi 2. So this equation can be written as ket psi is equals to E naught 5 ket phi 1 plus 12 ket phi 2. And after normalizing we get ket phi n, ket psi n. So psi n means normalized state. It can be written as E naught 5 phi 1 plus 12 phi 2 divided by 13 E naught. So basically psi normalized is 5 by 13 ket phi 1 plus 12 by 13 ket phi 2, and ket phi 2 is along the y direction, that is along the transmission axis of the polarizer. So the part A of question is probability that the photon will be transmitted through the polarizer is equal to coefficient of ket phi 2, because phi 2 corresponds to y2 axis, y axis, and y axis is also the axis of transmission of the polarizer. So it will be square of the probability amplitude, that is mod of square of coefficient of phi 2. So basically it will be 12 by 13 whole square. And part B of the question, it is asked that here, out of two given photons falling on the polarizer, one is transmitted and other is blocked. So it is asked that if two photons falls on the polarizer, and we have to calculate the probability that one photon will be transmitted through the polarizer and other will be blocked. So let's calculate it. So let's suppose P1 be the probability that photon will transmit, probability that photon will transmit, and P2 be the probability photon will blocked, photon will get blocked. So the total probability will be it is asked that out of two photons one gets transmitted, other will be blocked. So total probability will be P1 times P2 plus P2 times P1. So we can write it 2 times P1 and P2. So this will be 2 times 5 by 13 square and 12 by 13 square. So this will be our answer. And in the third part of the question, we have to calculate that out of two given photons falling on the polarizer, at least one will be transmitted. So we have to calculate, if two photons are falling on the polarizer, at least one of them gets transmitted. So in part C we have to calculate. So let's find the probability that no photon get transmitted. So this will be P2 into P2. The probability of for one of the photons gets not transmitted will be 5 by 13 square, that is P2 photon that will be blocked. So for photon, the probability that it will not get transmitted or will be blocked will be P2, and for second photon also will be, this is same as P2. So basically this is P2 square or 5 by 13 square and its whole square. So it will be 5 by 13 to the power 4. And we have to calculate that at least one of the photon gets transmitted. So probability that at least one of the photon get transmitted will be total probability, that is 1 minus probability that no photons will get transmitted. No photons get transmitted. So basically this 1 minus 5 by 13 whole power 4, and this will be our answer.